Good morning, children. So yesterday we have seen better how to find the equivalent fractions by multiplication and by division method. Now let us see some question. So it is question number 2 from your problem set number 17. Find an equivalent fraction with denominator 18 for each of the following fractions. Okay. And the first question is 1 upon. Now see children, you have to find the equivalent fraction of 1 upon 2. But what is given in the question? Denominator is 18. So you have to multiply this fraction in such a way that the remainder should become 18. So 1 upon 2. So to make this to 18, we have to multiply this denominator by 9. 9 is 18. And to make equivalent fraction, you have to multiply numerator also. So it becomes 9 ones are 9 and 9 twos are 18. Got it, beta? So in this way, you can find the equivalent fraction. Now let us see another question. Upon 3. Denominator should be 18. So to make this 3 18, we have to multiply this 3 by 6. So you must multiply numerator also with the same number. 6 to the 12 and 6 to the 18. So what is better? In this way, you can find the equivalent fraction. And the question is, denominator should be 18. Now let us see the another question on division. Find an equivalent fraction with denominator 5 for each of the following. So it is question number 3. Now the question has changed and it is not denominator should be 5. And the question is 6 upon 15. Got it, beta? It is 15 and you have to make it 5. That means what? See, to find the equivalent fraction, either you can multiply or divide. So by multiplying 15, you can't get 5. So you have to divide it so that it becomes 5. So by what number if you divide this 15 to get 5? So you have to divide this 15 by 3. Now to make equivalent fraction, numerator is also divided by 3. And the question 6 divided by 3. 3 2s are 6 and 5 3s are 15. Now see it better, our denominator becomes 5. So in this way, you can find the equivalent fraction by division method. Now let us see one more example. 10 upon 25. Again, you can't do the multiplication. Okay. So to get 5, you have to divide this 25 by what number? So that 25 becomes 5. So you have to divide this by 5. 5 times are 25. So denominator also divided by 5. 5 2s are 10. And 5 5s are 25. So in this way, you can find equivalent fractions by denominator 5 by division method. Got it, children? So let's see another term. One more question. Find two equivalent fractions for each of the following. From the following fractions given. Okay. So let's see one more example. It is question number 4. From the fractions given below. Pair of the equivalent fractions. And the fractions given 2 upon 3, 5 upon 7, 5 upon 11, 7 upon 9, 14 upon 18, 15 upon 33, 18 upon 27, and 10 upon 40. So what is question, beta? You have to pair the equivalent fractions. Okay, now see 2 upon 3. So it is a prime number. 5 upon 7, both are the prime numbers. Here 5 upon 11, 5 is 7 upon 9. So up to this, they are the prime numbers. Okay, and see 2 upon 3, 5 upon 7, 5 upon 11, and the last one is 7 upon 9. Okay, so you have to choose the pair from 2 upon 3. So you have to choose their pairs from the rest of the question. So by what number? If you multiply 2 upon 3, so that one of the is the any is the answer. Yes. So choose the. Now see children, 2 upon 3. So if you multiply, see it is 14. If you multiply this 2 by 7, so it is 15. But 7 is a 21. So it should not be the answer of 2 upon 3. 15. So 15 is not the multiple of this 2. So it is also not the answer. 18. Yes, 18 is the multiple of 2 and 27. So 18 means you have to multiply this 2 by 9. 9 2s are 18 and 9 3s are 27. Yes. So it is the equivalent fraction 18 upon 27. Now 5 upon 7. 5 5 upon 7. See again, 14 is not a multiple of 5. Yes, 15 is a multiple of 5. Means 5 3s are 15, but 7 is the 21. So it is not. 18 already we have choose. And now 10. 5 2s are 10 and 7 2s are 14. So if you multiply both numerator and denominator by 2, you will get 10 upon 14. Now 5 upon 11. So it is also, so you have to choose the answer from the given. 5 upon 30. See, again it is 14. Numerator is 5. So it is not a multiple of 5. Okay, so what is left now? 15 upon 33. Yes. If you multiply both numerator and denominator by 3, 5 3s are 15 and 11 3s are 33. Yes, it is the answer. So 5 upon 11 is equivalent to 15 upon 33. Now 7 upon 9 is left. So multiply this 7 upon 9 by 2. 7 2s are 14 and 9 2s are 18. So it is 40 upon 18. Okay, so in this way, beta, you can choose the equivalent pair. Got it, beta? Now let us see one more example. So it is question number 5. Find two equivalent fractions for each of the following fraction. Find two equivalent fractions for the following fraction. And first is 7 upon 9. Okay, now see beta, 7 is the prime number and 9 is the composite number. Yes, so divisors of 9 are 3 and the 9 itself. But 7 is the prime number, therefore it has only two divisors, 1 and the 7 itself. So no number, and you can't use 1 because if you multiply by 1, you will get the same number. Okay, so here we can't divide this fraction. Why? Because one is prime number. Okay, so to find the two equivalent fraction, we will multiply by any natural number. Okay, so you can multiply by any natural number to find equivalent fractions. But to find equivalent fraction by division method, you have to use only the common divisors of both numerator and denominator. So first 7 upon 9. So other than 1 and 0, you can take any number. So here I am taking 2. 7 2s are 14 and 9 2s are 18. So 14 upon 18 is equivalent to 7 upon 9. Again, but numerator and denominator. Okay, so both you have to multiply with the same number or you can divide with the same number. So see children, this 700 upon 900 is equivalent to 7 upon 9. So you can find infinite number of equivalent fractions using multiplication. Got it, beta? Now let us see another term, light and unlike fractions. So like fractions means what, beta? So fractions having the same denominators. Are known as like fractions. For example, see 2 upon 5, 1 upon 5, 7 upon 5, or 13 upon 5. See denominators 5, 5, 5, and 5. Therefore, these fractions are like fractions. Now, unlike fractions, fractions having different denominators. So here we are talking about only the denominators, not about the numerators. Okay. For example, see 3 upon 7, 1 upon 18, 7 upon 15, 100 upon. Now see children, 7, 18, 15, 3. So all these fractions having different denominators. Therefore, they are unlike fractions. So got it, beta? So fraction whose denominator are same are like fractions, and denominator whose denominators are different are unlike fractions. Okay. So bye bye everybody.